In Lesson 2.1, you will be writing rational numbers as decimals and decimals as fractions. Basically, numbers that can be written as fractions are called rational numbers. Right here in this box, we have some examples of rational numbers. Obviously, a fraction is already written as a fraction, so they're rational. Decimals can also be written as fractions. For example, 0.8 or 8/10 is 8/10 as a fraction. Whole numbers can be written as fractions by writing them over 1. Repeating decimals, such as 0.3 repeating, is the same as 1/3, so therefore that is a rational number as well. In our first example, we'll be taking and writing fractions as decimals. 5/8 really means 5 divided by 8. The fraction bar really is the same thing as a division sign. So if I wanted to change 5/8 to a decimal, I'm going to do the problem 5 divided by 8. The numerator goes right there, and the denominator goes right there. Now 8 does not go into 5, so we need to add a decimal point after the 5 and a 0, and put the decimal point straight up into the answer. 8 goes into 50 5 times, 6 times. 6 times 8 is 48. Then you'll subtract. 50 take away 48 is 2. We'll add another 0, and you'll bring it down. Now 8 goes into 20 twice. 2 times 8 is 16. Subtract. 20 take away 16 is 4. Add another 0. Bring it down. 8 goes into 40 5 times, and it goes in there 5 times exactly because 8 times 5 is 40. Now that I have a remainder of 0, I'm done with my division. The answer is 0 and 625 thousandths, or 0.625. At some point, you might get familiar with the eighths and know the decimal equivalent without having to do the division. Let's try a couple more examples. First one being 3/4. Many of you might know already the decimal equivalent of 3/4, but I'm going to go ahead and work that out. 3 divided by 4. 4 does not go into 3, so we're going to add a decimal point and a 0, put the decimal straight up. 4 goes into 30 7 times. 7 times 4 is 28. Subtract and you get 2. Add a 0, bring it down. 4 goes into 25 times. So the decimal equivalent is 75 hundredths. Next one, 3/5. 3 divided by 5. Actually, it's -3/5, so we'll want to make sure we remember they're negative in our answer. But now let's just go ahead and do 3/5, or 3 divided by 5. 5 does not go into 3, so we add a decimal point and a 0. Decimal point straight up. 5 goes into 30 6 times, and 6 times 5 is exactly 30. So we are already finished with that. It's -6/10. And for our last example, 4 and 13/25. This part of our mixed number is going to go before the decimal point, and then whatever 13/25 is as a decimal will go to the right. So I'm going to go ahead and do 13 divided by 25. 25 does not go into 13, so add a decimal point and a 0, decimal straight up. 25 goes into 130 5 times. I thought about quarters to help me with that, because 5 quarters would be $1.25, or 125 cents. Now when you subtract, You get 5 left over, add a 0, bring it down. 25 goes into 50 twice. So the 13/25 portion is 52 hundredths. So our answer is 4 and 52 hundredths. Every rational number can be written as either a terminating or repeating decimal. The ones that we just got done doing were terminating decimals, meaning they ended. If it terminates, it ends. If the division does not end, a pattern of digits repeat. If the division does not end and a pattern of digits repeats, the repeating decimals have a pattern in their digits that repeats without end. Instead of going and putting dots to show that it keeps going, we use what's called bar notation instead. And the bar goes over the part that's repeating. So in 0.333333, we write it like this with the bar over the 3. In this example, we put the bar over the 2 and the 8 because it's repeating 28, 28, 28. And in this last example, it begins repeating right here with the 1, 5. So we write the 7 and then the bar over just the 1 and the 5. So the part that's repeating is what gets the bar notation. In our first example of writing repeating decimals, we have -1 and 2/3. Well, I know it's going to be a -1 in front of the decimal point, and for after the decimal point, we need to figure out what 2/3 is as a decimal. So I'm going to do just like we did before, 2 divided by 3. 3 does not go into 2, so I add a decimal point and a 0. 3 goes into 20 6 times, which is 18. 20 take away 18 is 2. Add a 0, bring it down. 3 goes into 20 6 times. 6 times 3 is 18, with the remainder of 2, which means you would add another 0, bring it down. We keep ending up with the remainder of 2, which means we're going to keep getting a 6 up here. So it's going to be -1.6 repeating. We put a bar over the 6, the bar notation over the 6. Let's try just a couple more examples. 7/12. 7/12 would be 7 divided by 12. 12 does not go into 7, so I'm going to add a decimal point and a 0. 12 goes into 70 5 times. 5 times 12 is 60. Subtract, you get 10. Bring a decimal point down, or a 0 down. Now 12 goes into 100 8 times. 8 times 12 is 96. Subtract, you get a 4. 12 goes into 40 3 times. 3 times 12 is 36. Subtract and you get 4 again. If you were to add a 0 and bring it down, we'll have 40 again. 12 goes into 40 3 times. It's going to just continue on because we keep getting a remainder of 4. So if I were to write this one, it's the 3 that repeats. So 0.583 with the bar notation over the 3. Let's just try one more here. -2/9. I would go ahead and put a negative where I'm going to put my answer before I even start, because otherwise I might forget about it. Then 2 divided by 9. 9 does not go into 2, so I add a decimal point and a 0. 9 into 20, that goes in there 2 times. 20 take away 18 is 2. Add a 0, bring it down. 9 goes into 20, 2 times, 18. 2 left over. We keep getting a remainder of 2, so this one is going to be 0.2 repeating, or negative 0.2 repeating. I'm sure glad I wrote down that negative before I started because I almost forgot about it. We're going to go ahead and skip to the next example. We wouldn't want this video to get too long. It says, in a recent season, New York Yankees shortstop Derek Jeter had 6 hits in 22 at-bats. To the nearest thousandths, find his batting average. Well, he had 6 hits in 22 at-bats. So if I want to find his batting average, I'm going to go ahead and divide 6 divided by 22. 22 does not go into 6, so I'm going to go ahead and add a decimal point and a 0. Now 22 goes into 60 2 times. 2 times 22 is 44. Now when I subtract, I end up with 16. Add a 0, bring it down. 22 goes into 160 7 times. If you're not sure if it's 7, you could always try it out. 22 times 7. 2 times 7 is 14. 2 times 7 is 14 plus the 1 extra is 154. And then when you subtract, you have 6 left over. Add a 0. Bring it down. 22 goes into 60 twice. 2 times 22 is 44. When you subtract, you get 16. Add a 0. Bring it down. Now we want to know how many times it goes into 160 again, and we said that was 7. 7 times 22 was 154. You'll notice that it's repeating 0.2727, and if we kept going, it would be 2727, and so on. So our answer is this. However, it says to the nearest thousandths. Here's tenths, hundredths, thousandths. There's the thousandths place. You want to look one number to the right. And if it's 4 or below, let it go. 5 and above, give it a shove. Since this is above 5, it's 5 and above, we're going to move this up to a 3. So to the nearest thousandth, the batting average would be this, 273 thousandths. All right, now we're going to switch gears and we're going to take decimals and write them as fractions. Any terminating or repeating decimals can be written as fractions. If I want to write 0.45 as a fraction, I want to make sure to say that the right way instead of the lazy way. When I said 0.45, that was the lazy way. The correct way to say it is 45 hundredths. When you say the decimal correctly, it tells you the fraction. 45 hundredths. 45 hundredths can be simplified though because both the numerator and denominator can be divided by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. So 45 hundredths as a fraction is 9/20ths. Now this next example, the repeating decimal, is a little weird. In your textbook, they go through and explain how to get 0.5 repeating to equal 5/9. What I'm going to do instead is just have you see a pattern. If you look back at this one, 2/9 is 0.2 repeating. Earlier we saw that, oh shoot, it wasn't in here. 0.3 repeating is 1/3. 0.2 repeating is 2/9. Let's just go and write a couple of these down. 0.1 repeating, I'm going to tell you, is 1/9. 0.2 repeating, we saw earlier, is the same thing as 2/9. Many of you have already seen before that 0.3 repeating is 1/3. Well, 1/3 is the same thing as 3/9. 0.4 repeating is 4/9. 0.5 repeating is 5/9, and so on. Basically, if you have one number after the decimal point that's being repeated, you write that number over 9. If you have 2 digits repeating, after the decimal point like that, instead of writing it over 9, you write it over 99. And then you would go and simplify this. 12/99, 3 goes into both of those. 3 goes into 12 4 times, and 3 goes into 99 33 times. So that's kind of the little trick for repeating decimals. If it's 1 digit repeating, you write it over 9. If it's 2 digits repeating, you write it over 99. Let's just try a couple more quick ones for examples. Negative 14/100. When I say that correctly, it looks like this. Now, if I can simplify it, I should simplify it. Both these two numbers are divisible by 2. So 14 divided by 2 is 7. 100 divided by 2 is 50. And don't forget that it was negative. So negative 7/50. Next up, 8 and 75/100. 8 and 75/100. 75/100 can be simplified because the numerator and denominator can both be divided by 25. So we end up with 8 and 3/4. Now this is the repeating decimal that I was talking about up here. 2 digits are repeating, so we're going to write 27/99. Both the numerator and denominator can be divided by 9, so we're going to simplify it by dividing by 9. 27 divided by 9 is 3. 99 divided by 9 is 11. So 3/11. And the last one, this is one of our single digits repeating. So negative 1.4 repeating. It's going to be negative 1 and 4/9. It's over 9 because it's 1 digit after the decimal that's being repeated.